Good afternoon. We are on Trig point 12, and today we're going to go over a review of some of the basic problems that we've done. So here we go. Example 1. Find cosine of theta if sine of theta is 4 over 9 and tangent of theta is less than 0. Okay, you almost never go wrong by drawing a graph and finding the trig ratio. The thing is, sine is actually positive in two different places. Remember that in quadrant 1, cosine is positive and sine is positive. But in quadrant 2, cosine might be negative, but sine is still positive. So when this ratio comes out positive, there's actually two places it could be. It could be here, where theta is opposite over hypotenuse, so 4 over 9. But it could also be in quadrant 2 because sine is also positive in quadrant 2, in which case 4 would be opposite, 9 would be hypotenuse. So which one is it? This is where the second piece of information comes in handy. We need to know where tangent is less than 0. So remember, tangent is sine over cosine. So it's either going to be a positive sine over a negative cosine or a negative sine over a positive cosine. Those are the only two situations where tangent of the same angle would have to be negative. Well, in quadrant 1, a positive divided by a positive is a positive. So they can't be in quadrant 1 because sine over cosine is a positive tangent. So no. That leaves us with quadrant 2, which makes more sense because a positive sine over a negative cosine, a positive divided by a negative, is a negative tangent. So that's how you figure out which quadrant your answer is in. It is in quadrant 2. So now we're in the position of finding sine of theta. We want to find cosine of theta. And cosine of theta is adjacent over hypotenuse. We're in this quadrant here. So we need to find the adjacent sides. I'm just going to call that x, and we're going to use the Pythagorean Theorem to find the missing side. So here we go. X squared plus 4 squared equals hypotenuse squared, 9 squared. So x squared plus 16 equals 81. Subtract 16 from both sides, you get x squared equals 65. Take a square root, x equals radical 65. So x is radical 65. We are now ready to find cosine of the angle. So cosine of theta equals adjacent, which is radical 65, over hypotenuse, which is 9. And 65 doesn't simplify out. Now we have to decide what the sign is on this, positive or negative. Well, in this quadrant, cosine is negative, so my answer is going to be negative radical 65 over 9. So again, we found the two places where sine could make a positive ratio. Then we figured out where tangent was negative. Because the two things have to be true, we had to be in quadrant 2. And that's what tells us that cosine on our answer is negative. All right, so that's our first review example. So example 2, evaluate, which means get a value. We're going to evaluate cosecant of 4 pi over 3. Okay, so again, we're going to make a little graph here. And the unit of measurement is by thirds. So we have 1 pi over 3, 2 pi over 3, 3 pi over 3, and here is where our 4 pi over 3 leads us, right here. Which means that your reference angle to the nearest x-axis is pi over 3. So cosecant of pi over 3 is 2 over radical 3, and when you rationalize, it's 2 radical 3 over 3. That's your base angle. So now we need to figure out the sign on it, whether it's positive or negative. So remember that cosecant is 1 over sine. So whatever the sign is on sine, That's our cosecant. So in this quadrant, which is quadrant 3, you have a negative x and a negative y, which means a negative cosine and a negative sine. Because sine is negative, cosecant is negative, and our answer is negative 2 radical 3 over 3. So the reference angle gives you the base, but the quadrant tells you if it's plus or minus. All right, example 3. Given an angle that equals 60 degrees, I want you to find a positive coterminal angle and a negative coterminal angle. So coterminal just means looks different but lands on the same spot. So let's draw a graph, and we've got a 60-degree angle, which is about there. So that is your 60-degree angle. So we want a positive angle that lands on the same spot. So the way you do that is you go in the positive direction, which is counterclockwise. We go all the way around to 360, and then we add 60. So 360 plus 60 degrees is 420 degrees. So our positive coterminal angle is 420 degrees. Now, to find the negative coterminal angle, we're going to go the other way. So negative is always clockwise. We're going to go around and stop at the 60. So there's a couple ways to do this. One of them is to recognize that if this is 60, the remaining piece here is 30. So I can take 270 degrees and add 30, which gives us negative 300. So our negative coterminal angle is negative 300 degrees. From here, if you needed more positives or more negatives, you would just keep adding or subtracting by 360. So once you found the original one, you just keep adding 360 degrees to get as many as you need. In the case of the negative angle, you subtract 360 to get as many as you need. So that's positive and negative coterminal angles. All right, example 4. This is a review. So given the angle negative 240 degrees, I want you to change it to radians. Okay, so in order to change from degrees to radians, you need the conversion fraction, which is pi radians equals 180 degrees. So take the angle you're going to change, so negative 240 degrees over 1, and then you're going to multiply it by your conversion fraction, which you're going to position so that degrees cancel. 240 has degrees on top, so my 180 degrees goes on bottom. My pi radians goes on the top. This causes the degrees to cancel. And now I've got negative 240 pi over 180, and I simplify it. So knock off a 0. Let's see, 3 times negative 24 is negative 1, and it's 3 times 8 is 24, and a pi. On the bottom, 18 is 3 times 6, lose a 3. 8 is 2 times 4. 6 is 2 times 3. Lose a 2, and you've got it, negative 4/3 pi. And that is radians. Whether it says so or not, it is radians. All right, let's go backwards then. Last one. Given an angle 11 pi over 4, we're going to change to degrees. All right, so the conversion fraction is the same. Pi radians still equals 180 degrees. Now this is already a fraction, so you can just go 11 pi over 4 if you want to write the word radians or rads in there to see where it's at, it's actually on the top of the fraction. So when we use our conversion fraction, we're going to put the pi radians on the bottom and the 180 degrees on the top. That way, radians on top, radians on bottom cancel. Now, the other thing that cancels are the pi's, pi and pi. So what we've got left is 11 times 180 degrees over 4. So we need to simplify. 180 is 18 times 10. So 332 for the 18, 2 times 5 for the 10, over 4, which is 2 times 2. Divide out a 2, divide out another 2, and multiply what you have left, which is 11 times 9 is 99, and I got to go 99 times 5. Let's see, 45, 49. So 495 degrees would be your answer. All right, I know that was a brief review. I just wanted to touch on some of the problems that you will be seeing on upcoming quizzes. Have a good rest of your day.